Question: in a 100-meter sprint, a runner starts from rest and accelerates to 9.6 meters per second west in 4.2 seconds. A. Calculate the acceleration of the runner. B. Calculate the displacement of the runner. C. The runner runs at a constant velocity for the rest of the race. What is the total time? So the total displacement of the runner is 100 meters west. And we can divide the total displacement into two sections. The section 1, displacement 1, and section 2, displacement 2. So the section 1, the displacement 1, is for the accelerating stage, and the displacement 2 is for the constant velocity stage. So the time interval for displacement 1 equals 4.2 seconds. And the time interval for displacement 2 is delta t2. And the initial velocity of the runner is 0 meters per second. And the final velocity is 9.6 meters per second west. And the time interval for the accelerating stage is 4.2 seconds. So A, the acceleration equals the final velocity minus the initial velocity divided by the time interval 1. And this equals final velocity 9.6 meters per second west, and minus the initial velocity 0 meters per second divided by time interval 1, 4.2 seconds, and this equals 2.3 meters per second square west. And B, it asks for the displacement of the accelerating state. So it is delta d1. Delta d1 equals 1 over 2 multiplied the final velocity plus initial velocity multiply the time interval 1. And this equals 1 over 2 multiply 9.6 meters per second west plus 0 meters per second multiply the time interval is 4.2 seconds, and this equals 20 meters west. And question C, it asks for the total time. So the total time equals the time interval 1 plus time interval 2. Now we already know time interval 1, so we should find time interval 2. So time interval 2 equals the displacement 2 divided by the final velocity. And this equals the displacement 2 just equals the total displacement minus displacement 1. The bottom is the final velocity. Now this equals total displacement is 100 meters west, and minus the displacement 1, 20 meters west. divided by the final velocity 9.6 meter per second west. And this equals 8.3 seconds. Then the total time equals the time interval 1 plus time interval 2 and equals 4.2 seconds plus 8.3 seconds, and this equals 13 seconds.